Alright. Oh, can you hear me now? I think I mistakenly clicked on the mute button. Can we all hear me now? All right. Thank you very much, Moses. Okay. All right. So I was saying let's give 2 more minutes now to more people to join in. Um, so by 7:05 we will start. And I was asking how our day went and hope the rain did not disturb our day. Good evening, Prega. Good evening. I uh I hope the rain that fell will not affect our network so much today. Because it seems in Nigeria once it rains, the network scatters. Oh Miracle, sorry. Do you want a cup of tea? Idiri will provide tea. Idiri will provide a very hot cup of tea. Just send your house address. The tea will get to you. Oh, happy, thank God that your day was fine. My day was okay, a bit under the weather, but I'm better now. Okay, we have 1 more minute. 1 more minute for more people to join in. Yeah. And it's 7:05 on the dot. So we can get started, I believe. So I'm ready to get into today's topic. How many of us are ready? We're doing well, we're already in week 6. Just like yesterday, we started week one, Introduction to Cloud Computing. And already we are in week six, looking at databases. Okay. All right. So let's get into it. So this week is focused on databases in AWS, and I'm sure Mr. Moses did a good job yesterday on Monday, introducing us to relational databases, right? RDS. And For today, we're going to be looking into another aspect of what's it called now, database, right? Which is the Amazon DynamoDB, and is also known as the serverless database, right? So, this aspect of cloud computing, database, and everything, right, is majorly there are people that specialize in, for those that are into data analytics and wants to come into cloud computing, right? Data analytics, database administrators, right? This is a very important aspect. But for someone who is still, like for us that's just starting, right? It's good to know a bit about everything. So even if you're not going to specialize in database, right? AWS expect that you at least have the basic understanding of every aspect of cloud computing, which is why we've talked about uh, EC2, we've talked about networking, right? Even though there are people that actually specializes in networking, but it's good that you have an idea of how everything works, basic understanding of everything in AWS. So for us to get an understanding of what DynamoDB is, right? So I'm starting from the basics, help us to further understand the types of database that we have, and then we'll move on from there basically. All right, so what are databases? Someone said they can't see my screen. Ah, can we see my screen now? Is it moving now? What can we see on my screen at the moment? Let me know what you're seeing on my screen at the moment. I have databases on my screen. What is database? Admin, please remove my face so and put the slide. They can't see my slide. They can see my face. Please, can we assist with that, please? Okay, Josiah. Okay, I've stopped sharing and I've reshared again. So, is it better? Can we see it now? You still can't see my screen. Okay, and do we say they can see it now? Okay, all right. Okay, thank you very much. Yes, so exactly, it's supposed to be showing what is database. So that's where we are at right now. All right, so like I mentioned, right, I'm going to be starting from the basics so I can understand when we go into DynamoDB, right, and understand where we're coming from basically. So database is basically your collection of data, right, that's stored electronically. This is something that you would have covered yesterday, so I'm not going to talk too much on this one, right? You need database to help you store data and to manage your data efficiently. It's just like an organization that's, or maybe an e-commerce company that deals with selling of different goods and products. Look at Alibaba, for example, right? they have to have a database where all of their products information is stored, their vendors information, um, maybe even their own staff's information, right? So they will have database that would contain all of this information basically. So database helps to keep your data organized and to ensure data security and consistency. So it will not make sense that somebody has data on one person has data for product on her own laptop and that person has it in her own laptop. This person is deciding to save the name of a product as television, and then another person decides that it's TV that is going to write, right? When you're using a database, it allows consistency, right? Everything is in a central location. If you need to get a data on a particular product, you know that you are going to this database. You're not looking for Amaka or Chukugozie to give you the data basically. So a database gives a centralized place where all your data is and where you can organize your data as you want it for easy access. Now, there are two major types of databases, right? You have the relational or SQL database, that's what they call them, relational or SQL database, and you have the non-relational or what is called the NoSQL databases. Right now, relational database is what Mr. Moses dealt with on Monday, so we're not going to be looking into that. So for non-relational databases, they are majorly four. They fall under four categories as well. You have the key value, you have the graph, you have column, and then you have document. So all of these categories basically kind of explains how the data are structured inside that database, right? So today we're going to be focusing on Amazon DynamoDB, right, which is a NoSQL database, which means it is not a relational database. Um, DynamoDB is actually under the key value category. Is an example of a key value non-relational database. Now, what's the difference between a relational database and a non-relational database? Now, I'm giving all this to kind of set, you know, a foundation, so to say. Please, if at any point you cannot hear me, please always call my attention. I'll try to be moving back and forth between the my slide and the chats and the chatbot. All right. So I was saying that difference between relational database and non-relational database, like your DynamoDB, in terms of structure, right? Your relational databases are usually stored in tables. If you've seen the example that Mr. Moses would have shown us on Monday, right? You have your database, your data is stored in tables where you have rows and column, right? So you have rows. Every row will contain attribute about a particular um, record, right? Every row is usually called a record, right? So data is stored in rows and column for a relational database. Now, for a non-relational database, there is no fixed data structure. The data can be stored in key value pairs, can be stored in a document format like your folders, right? Like having a folder where maybe you have a folder for maybe a cloud computing class in a Incubator, and then in that folder you now have folder for students. In that student folder you have another folder that contains all the list of students name, right? For every student's name there's a folder that now has all the information of that student basically. So data is stored in document form for documents DBs, right? While for key value pair, we're going to be going into it since that is what DynamoDB is. So just calm down and follow along. So that's one of the differences between a relational and a non-relational database, which means that for relational database, your structure is rows and column. For NoSQL databases, there's no fixed data structure. It is flexible. It can be in any kind of format. For schema, now schema is basically how your data must fit into a particular format, right? For relational databases, there has to be a predefined schema. Say if you are creating a table for a relational database now, right? Maybe you want to create a table for students. You have defined it that in this table, right, the schema is going to be student ID, student's name, um, course that the student is registered for, maybe student's phone number, student's email address. It is fixed, those five things, which means that if you want to impute the data, maybe you now to input the for each of the rows now, right? Row one is maybe student's ID one. For that student ID one, it is expected that that data you want to impute must have the student ID, the student's name, the course that the student is registered for, right? The phone number of the student, all of those things that you have initially defined before even inputting your data. So there's a way that the data must fit into the format that you have already uh, predefined, right? So for a relational database, it has a predefined schema. While for a non-relational database or a NoSQL database, whichever one you prefer to call it, right, it is schemaless, which means it doesn't have to fit into a particular format. For you can say a student now, you can decide that that student will have student ID. The student might decide not to give you the name, instead will give you the course, right, that he or she is doing. So it can be in any format, and there'll be nothing that would it will not show you error when you want to impute it into the database, right? So then in terms of scaling, for a relational database, it scales vertically. And when we say scaling vertically, it means that if, for example, you've purchased a particular instance type that your database will be sitting on, right? Maybe you said the data instance type that would or size that was going to fit my database. Maybe it's just a small database I have, so I only need a 2 vCPU and a 4 gig RAM instance type, right? If for any reason you need to add your data increases and you need more capacity, right? What it will do is going to add more, it's going to increase your instance size. So it's going to increase from maybe a 2 vCPU 4 gig RAM to maybe a 4 vCPU 8 gig RAM. But for a non-SQL database, what it will do is instead of just increasing the power, is going to add more server. So if you've done 2 vCPU 8 gig RAM, you're just going to be adding more of that same thing to it. So it will keep adding databases. So it will not increase it, it will be adding it. So instead of having just one server of 2 vCPU, you can have like 2, 3, 4 servers, depending on how much your data has grown, basically. Then in terms of use cases, right, relational database are ideal for structured data that is structured. They have clear relationship. Nothing is changing it, right? While NoSQL databases are great for unstructured or rapidly changing data. Unstructured or rapidly changing data. So if your data can be in any kind of format, then it is advisable that you go for a NoSQL database. If you know that the kind of data you're going to be getting is a data that does not have structure, people can feel different things, then it is better that you go with a NoSQL database. Then example of relational database are like your customer databases that have structure. You have structured it that name, email, addresses, those things are fixed. It has a fixed schema, right? While for NoSQL, example are like your social media platforms. Social media platforms, some people might have a username. In their username, after username, they can decide to include their full name. Some might decide that it is a nickname they want to add, different things. Different posts of the people that are posting or of those social media users, right, can vary, right? One day somebody might decide that it's picture that he wants to share, another person might decide that it's video I want to share. So there's no fixed structure, right, for a NoSQL database. All right, so example of a relational database, and when I say it as a fixed schema, right? I'm sure you saw something like this on Monday when Mr. Moses was teaching us, right? Um, Bimpe, we'll talk about this after the class, please. All right, I've noted that. We'll talk about this after the class. Thank you. Okay, so as I was saying, right, this is an example of a relational database. We saw this on Monday, most likely. And when I say it has a fixed schema, now for this particular table, right, what the person that's created this table in the database has defined is that there is going to be an employee number, there's going to be last name, there's going to be first name, there's going to be department. So by the time you want to input information into this table, that information, every row must have this information. Every role must have this information. This person now cannot come and say, okay, I'm going to put first name, I will not put department, or he's going to put first name and then now put department here and then put first name after department. It cannot work like that. For a relational database, it is structured and it is fixed, right? But for a non-relational database, this is an example of what the table looks like. So you have this table called people, right? In a non-relational database, right? In a table in a non-relational database, one thing is what is fixed, right? That is compulsory and it's depending on what you actually set, which is your partition key. So partition key is like your unique identifier. I will explain more when we get into DynamoDB itself. But you can see what this table is. Can you note the difference between this table here and the first one that I showed us in terms of their arrangement, right? You see that for this person one, right, this item one here, this person has last name, first name, phone number. This person, item 2, has last name, first name, address. It does not even have any phone number. So there's no column for phone number for it. So that is why a non-relational database does not work with column and rows in quotes, even though it's also in a table, it can be in a table format, but there's no fixed schema. There's nothing like, oh, by force by fire you have to have this particular data or this particular structure. Again, another thing that you can note is that in this address, there's more than one information in this person's address. So it can also be broken down into streets, the main city of the person, the postal code of the person, the state of the person, etc. Right? So now look at the third item here. It has last name, first name, favorite color, address. So there's no structure to it, right? There's no structure to it. It's like if I tell all of us now that write, tell me about yourself, right? Write 10 things about yourself. Different people write different things, isn't it? Um, Different people would. I'm seeing something from Api. Bimpe is not the only one, please. Okay, for those that you said you sent me your assignment directly on the LMS, I think I've seen one where you did just after the class, please just private chat to me. Thank you very much. All right, so as I was saying, right, for a non-relational database, there is no structure. It is as the breeze directs. If I ask all of us here on this call that I want you to write about yourself, maybe I want to build a database with everybody's information, right? And I say, write about yourself. Some people will write about themselves, they write first name, last name, right? They will write their address. Some will put their date of birth. Some will put the exact, they'll put their age. right? Some will put favorite color, best food, while some people that are minimized be like, what does this teacher want to do with my detail? I will only put things that should concern her, and they will only send their name, their phone number, email address. That's all. So if I want to save that kind of a data in a database, right? If I decide I want to use a relational database, I'm going to have issues. Why? Because all of you have different way you structured what you've written. And for a relational database, it has a fixed schema, which means that if I'm going to input everybody's data into a relational database, I'm going to keep getting error, because where Shade has given me name, first name, last name, address, and phone number, and then Happy has given me first name, last name, email, favorite color, favorite food, name of spouse, the street she's living in. There is no schema to cover the favorite color or favorite food that she has imputed. So there's no way I'm going to put it in a relational database. And that's why a non-relational database is usually recommended for data that does not have a fixed structure. You are not sure of how it's going to come, basically. All right, so let's now get into DynamoDB itself. So what is DynamoDB? DynamoDB is a NoSQL key value database service. Remember I said that under a NoSQL database, right? So you might hear me using NoSQL and non-relational database interchangeably. They basically mean the same thing. So a relational database is also known as a SQL database, while a non-relational database is also known as a NoSQL database. Now, under that NoSQL database, there are different types, like I showed us in the graph at the beginning. You have the key value, you have graph, you have column, you have documents. So DynamoDB belongs under the category of a key value database service, right? And another thing to note is that it is fully managed, it is scalable, and it is serverless. So unlike your RDS that you have to select an instance type, you are at um it is your responsibility to select the kind of instance type that you want, the kind of server that will be hosting your database, right? Unlike that, for DynamoDB, it is not using. Remember when we talked about serverless and we talked about Lambda and talked about how it is doesn't mean that it's not going to be using a server. It just means that AWS will be the one to choose what kind of server that it's going to be sitting on, depending on the amount of data that you have, basically. So, why is it important to use DynamoDB? Number one is that it will automatically scale as your data is growing. So, if today you have just 3 items in your table, it will only provision what is needed for that 3 item. If your items in the table increase to 10,000, it's going to automatically provision more to accommodate that table. So you don't have to go and manually increase your size. It also handles massive amount of data with minimal latency. Basically, we've talked about latency before. Then talking about how fast you're able to get information that you need from something, right? Then also you don't need to manage infrastructure because it is serverless, right? Which means that AWS is managing everything for you, everything for you. Now, when I say something is a key value system, this is what I mean, right? So it's just like your dictionary. In a dictionary, every word is a key, and then the definition is the value of that key, right? So in a DynamoDB, it is your data is stored in a key value pair, right? In a key value pair. So the key is unique, is a very unique identifier, while the value is going to be the information of that key, basically. Say for example, this is a key value system here. Customer ID is a key, Now, what is the value of that customer ID? 123. Name is a key. What is the value of that name? John Doe. So this whole thing here, right, can be for one person, for one item, right? You can now have another one. Customer ID will be equals to 124. Name, Onoa Happy. Email, onoahappy@example.com, right? And then maybe the orders of this person. Now, if you notice, under the orders, this person has more than one order, right? Which means that for this kind of a person now, right, all of the information you need is here. For a relational database, right, you are going to have a table for order separately. You are going to have a table for customer separately. So if you want to check maybe the order that you are going to now start using the primary key, right? The primary key that is in the customer table and in the others table, like I believe Mr. Moses would have explained to us on Monday, right? So a relational database would have primary key in different tables, and then different keys of different tables will be referencing that primary key basically. So this is what a key value storage looks like in DynamoDB. So this one now is like for one item. This is relating to item 1 to 3. So there can be another um you can write for another person down now and say customer ID 1 to 3, name. If the person does not give you email address, no email address. If the person has not ordered anything, there is no order that you will put for it. There will be no fight, basically. All right. So far, I hope you can still hear me. Okay. All right. Thank you very much, Happy. Okay. So components of DynamoDB, and this is where it starts becoming interesting. So we're going to look at all of these things that I've put here, right, deeper into the slides. So component of a DynamoDB, one is tables, you have items, you have attributes, you have partition key, and sort key. Now, what is table? Table is like just like you have a relational database, right? It is what is going to store all your information basically. So a table stores items. Now, for DynamoDB, instead of rows, they are called items. So your items are like your rows in a relational database. And each item is a collection of attributes like column. But the difference is that in a DynamoDB, you don't have fixed column. It can be anything for different item. Item 1 can have an attribute of a name, address, phone number. Item 2 can have an attribute of name, phone number, favorite color. Item 3 can have attribute of phone number, favorite food, favorite color, name of secondary school. So there's no fixed thing. That's the difference between relational and non-relational. But a table is what houses all of those information, the items and the attributes of that item. Say, for example, if your item is Onoa Happy, right? Onoa Happy is the item. The attributes that she has given you, like maybe her favorite color, date of birth, the name of her secondary school, the year she graduated, right? All of those things are attributes of Onoa Happy. Do we get that? So that is what the table will comprise of, all of those things. And like I said, an item is what different things that have different set of attributes. So Onoa Happy can be your item 1, Levina can be your item 2, right? Folashade can be your item 3, Ediri can be your item 4, and each of those items can have different attributes. So are we seeing how they are entering inside each other? So a table will contain item and attributes. Now, an item is what is a unique record inside that table. An item is a unique record inside that table, and an item can have different item can have different attributes. Now, attributes are things that describes that item. Attributes are things that does what? Describe that item. Like I said, like your name, your date of birth, your if for example now maybe is a data of a store that we have. A an item can be product ID, right? Maybe product ID is a product ID one, right? The attribute of that product ID can be the product name, right? The size of the product, the color of the product, the use of the product can be different things. So attribute are what is describing the item. Now, partition key. A partition key is something that is very, very mandatory in a DynamoDB. It's similar to your primary key in a relational database. It's similar to it. So it is a unique identifier for each item. Your partition key has to be a unique identifier. So you cannot have um, one person sharing or two people sharing the same partition key. If, for example, now we want to create a database for students in cloud computing, right, in Lita, and then we are trying to create this table, we have to give it a partition key. We can say partition key can be name, right? We can say partition key can be name. But the danger of using a name as a partition key is that two people can have the same name, which means that it is no longer what? Unique, right? Two people can have the same name. I even have people that have the same name, first name and surname, right? So it means that you will not want to use a first name to do a partition or to be your partition key, because it cannot be unique across board. One day you can have a student that will have the same name, you can have another Esther Benson, right? So it is not unique. So what we can do is we can decide to give every student a student ID, just like you have on your LMS. You see that everybody has an ID, like their LMS ID, right? That ID is what is unique. No two students has the same ID. So your partition key becomes a unique identifier for each item, which means that if I'm going to find out how many students do we have in cloud computing in liter right at the moment, instead of me going to go and count the number of names we have, I'm going to count the number of what primary unique identifier, which is like our student ID, right, that we have. Why? Because it is unique. It is unique. So one student, one ID, one student, one ID. So that is what your partition key is. It is a unique identifier. It is a unique identifier, and it is compulsory. When you want to create your table in DynamoDB, you must state what your partition key is going to be, right? In that example that I showed us earlier on of this thing here, right? In this place, can somebody tell me what can be our partition key in all of these attributes? Which attributes can we say is our partition key, or can we use as our partition key? Let me see if we're following and understanding. Customer ID. All right, thank you very much. Customer ID. So yes, in this example, you find out that customer ID is what we can use as our partition key. If we say we want to use others as partition key, we're going to have issue. Why? Because some people might not have any other. They might just have, some of us have signed up on Amazon or Alibaba Express and we have never ordered anything, but they have our details. Why? Because we have signed up on it. So if what are they calling it now, Alibaba wanted to say they will use orders as their partition key, it will not work because some of us don't have any order that we have made. But if they made it that whenever somebody is signing up to Alibaba, a unique ID is given to every person that signs in. So that unique ID becomes what? The partition key. So every other thing that follows becomes an attribute of that key, of that item, right? Hope we get it. Do we understand so far? All right. So moving on now, we have the last component, which is a sort key. Now, what a sort key does is that it helps to organize data, right, within the same partition. It will help you to organize data within the same partition, and it allows for what? More flexibility in sorting the data. I'm going to explain all of these attributes with a picture, right? So, can we all see the picture? Oh no, I said we just store the others in the cart. Abijay, one day we'll buy them. One day we'll check out. Okay. All right. So looking at this image that is on our screen now, right? In a DynamoDB, so this is bringing everything together. You have the table, right? The table is housing everything. Now, in this table, you have three items: item one, item two, item three. These three red boxes are your items, right? Now, in these three items, you have different attributes. You can see that item two has how many attributes? One, two, three, four. Now, because a partition key is what? Is compulsory, most times it is not considered as what? As an attribute, right? So you have a partition key and then every other thing becomes an attribute of that key, basically. So for item three, right, it has a partition key, a sort key, and what? And two attributes. So maybe let's say for students in liter. Now let's assume that this table is for students in liter. So we have student ID, right? Now a sort key can be something that uh you can use to sort, also sort or to organize the data, right? In apart from the partition key. Now our sort key can be, if we have the data of all the students in liter, right? Our sort key can be the course that they are doing. So you can have a course code here as your sort key, right? So you have your partition key, you have your partition key as a student ID, you have the course that they are doing. So which means that I can say that I'm looking for um student ID 1234, right? That is studying cloud computing. So this is going to then sort out the data for me based on those attributes that I've given it, right? So every other thing that follows are just an attribute. Now, two things to note. Your partition key is what? Is compulsory. It is something you have to set once you are creating a Dynamo table. You must decide that this is what is going to be your partition key. Now, a sort key is optional. It is optional. You don't have to say that you are going to have a sort key. You don't have to. But once you say that there's going to be a sort key in your table, right? Once you determine that there's going to be a sort key in your table, that sort key cannot be empty. That sort key cannot be what? Empty, which means that it is not going to become, it's now a mandatory thing for you to fill whenever you are filling in data. Say if we have said that our partition key is student ID, our sort key is the course that they are doing, right? It means that whenever I want to update data into this table, maybe I want to add a new item now. So item one, number one is what is compulsory for me to have the partition key for that item. So partition key is what? Student ID, which means that I must have the student ID of this new item I want to add. So I'll put the student ID. Now, if at the time I wanted to create the student the table, I say, oh, I don't need sort key, it will not be compulsory for me to put their course. But once I state it that I want to have a sort key in this table, and I'm saying that, oh, my sort key is going to be the course that the student is enrolled for. When I'm including a new item here, compulsorily I must include the course that the person is enrolled for, right? Now, this other attribute, this item one's attribute has just one attribute, right? Maybe it can be just the name of the student. This person, the attribute here can be the person's first name, last name, email address, phone number. Then maybe this person here only puts first name and last name, right? The new person I want to put can have first name, last name, email address, phone number, favorite color, or it might decide I will not even put first name and last name and only have email address, favorite color, right? So all of these data, right, are stored in partitions. So that's why you have partition key A. Partition key A is, the partition for each of what the items that you have here. So partition key A, partition key B, partition key C. Your data is basically organized in what? In partitions. Now, what does those partition key means? Right? Partition key, like I said in the earlier example, right, is unique identifier. Your partition key has to be unique. Your partition key has to be what? Unique. A DynamoDB uses the partition key to distribute data across multiple servers for efficient access. So it uses that partition key to distribute your data across multiple servers. An example of it is in like a user table, like email, for example, right? Because emails are unique, you can also use an email, right, as your partition key, because no two person will have the same email address. It might just be one letter that is the difference between the two email, but they can never be what? The same email address for two people. So you can say that your partition key is going to be what? Your email address. Now, aside from your partition key, you now have a what? A composite key. Now, a composite key is a combination of your partition key and your sort key. A composite key is a combination of your partition key and your sort key. So it combines these two attributes together to uniquely identify an item. Let's say if you have an order table now, right? You can say that your customer ID is the partition key for that table, right? And then your sort key is going to be your order date, right? So which means that what you have done there is that you now have a composite key, which means if you want to search for something, you can decide that I'm going to search for customer one with order dates 24th of September 2024, which means it's going to bring out what? All the attributes of that customer for that particular order date. Maybe it's going to list out all the things that she ordered on that day, how much it is that she spent on that day, and all of those things, right? So a composite key would compose of or combine your partition key and your sort key together. Now, let's try something here. We have this table, right? Student ID, course code. These are your different attributes, right? Now, when you're creating this table, you have put student ID, course code, name, email, grade, phone number, address, right? When you want to create table, one thing is what is compulsory for you to fill for put. one thing, which is your what? Your partition key. In this table, which one do you think should be our partition key? That is a unique identifier. Which one is our partition key? Let me see if we are going to get confused. Okay, okay. All right. I like that I have different answers. Okay. So let's go back. The people that said email, yes, you are right. But then again, it is dependent on what it is that you want. Now, for this particular table that I have created, right? An email can be your unique identifier, isn't it? Because it is unique all across the board, right? But in this case, I'm going to do what? Advise that you do what? Have a student, you use the student ID as your partition key. That you use the word student ID as your what? As your partition key. So in this table, we have our partition key as what? As student ID. And I'm going to explain why going forward. So as I went on to create this table now in my DynamoDB, I have only stated that I want to create a table. My partition key should be student ID. My partition key should be student ID. Now, if that's the only thing that I stated, it means that all of this other information here becomes optional. It means that whenever I want to fill, Alice can come here and fill her course code, her name, email address, her grade can be added, her phone number, her address. She can, while Bob can come and say, it is only my name and email address that I want to do what? That I want to give. Now, why can't we use a course code as our partition key? The reason why is because students are the ones taking the course. The course is not the one taking the students, right? Which means that Alice can be taking CSC 101 and MTH 101. Bob can decide that it's only CSC 101 that is going to take and not take MTH 101. Now remember that your partition key cannot be left empty. You cannot have a empty slot in your partition key, right? So if I now say Bob now want to fill in details for Bob and now put 102. Our partition key is CSC and the course code, right? But Bob is not taking anything. He's not taking any course yet. He has just registered. He has not yet decided on the course he wants to take. There will be no way that the database will accept him because the partition key is what cannot be left empty. But when it is that the student signs up to the school, whether they've applied for their course or not, they get a student ID, right? It will automatically assign a student ID. So by default, you know that there's no mistake that wants to happen. Every student will have a student ID. Just by default of them what signing up. So your student ID becomes what? A partition key. Now, I can also now include that to make things easier, I can decide I'm going to add a sort key. So when I want to create a table, I'll say, okay, DynamoDB, this table I want to create, the partition key is going to be student ID. I want a sort key too. Sort key is what is going to help me to be able to, kind of organize the data much more granularly, right? So I make my course code a sort key. I make my course code a sort key. So what would this do now is that what this on a normal day, right? Um, on a normal day, if I want to get information from this table, if I say give me students 101, right? It's going to give me all of the attribute of student 101, with all the course that student 101 is signed up for. But when I put a sort key to it, now these two, partition key and sort key, is what is forming your composite key. A combination of your partition key and your sort key becomes your composite key. Now for this table, I can now decide that give me information on student 101 for MTH 101 or for CSC 101, right? So within this partition, this 101 partition is going to look for what I can sort it based on this course code. Again, it is dependent on what you want. But note that once you decide that you are going to also have a sort key, that sort key can also not be empty. Once you decide that you are going to have a sort key, it means that that attribute must always be filled for every item that you are going to input. That attribute must be filled. Now, aside from these two, now every other attribute here becomes optional. Some might have the details, some might not have the detail, and so on and so forth. Right. So, is there any question on this for now? Do we get this, or is there any question? So, Onoa happy. If what are they calling it? Does it matter that the partition key has to be in the first row? Most of the time, yes, that's where it's going to be. Because as at the time when you're even creating the table, right, is the only thing that you are going to tell DynamoDB that is compulsory, right? So most of the time it falls in your first column, not the row now. Again, remember that for a DynamoDB, you don't really have a fixed column, right? If you look at this, I'm trying to go back to that slide. If you look at this particular table, can we see this table? The example of a non-relational database that is here. Can we see that the table that has example of a non okay, all right, okay, thank you. Now if you look at that table, you see that your primary key, because your partition key is the identifier, is your unique identifier, it would most likely do what always come first, because it is what your unique identifier. Because when you want to input a new item, right, that is the first information that you are going to input. Without that information, the database will not even accept what you want to input into it. So you see that most times those what is going to always be the first that you're going to see for every item. But every other thing will do what can be, if you look at the second item 102, you see that it has last name, first name, address, right? While for item 103, it has what? Last name, first name, favorite color before address. So for the other things, they can fall as they want. It can, so that's why you don't have a fixed column for each of it. Item one can have two columns. Item one can have three columns, and the columns might not even fall under each other, basically. So this is actually a perfect example of how the table looks like. It can be fluid. The only thing that is constant is what is your partition key. Now in this partition key, if you now decide to add a sort key to it, after the partition key, the sort key will follow. Does that answer your question on Yeah, so for our attendance data now, right? For that one, there's a fixed form, there's a fixed schema, there's a fixed structure. You are expected to fill your let's say if we create a form now, say this form you are filling name, um your student ID, your email address, and all of those things. I have put a schema to it, which means that for you to submit that form, you have to fill all of those informations, because if you don't fill those information at the back end, the database is not going to accept it. So it is not by the form, right? It is based on what is at the back end of that form. What you are seeing is the form. There's the aspect of the form being uploaded to a database. So whether they've told you to fill email address first or first name first, as at the database, the back end, the database that Incubator is going to be putting all those information in, depending on what the person has set there. If the person has set that, or his email address that is going to be the partition key, then email address will be the partition key. But it's not dependent on what you are filling on your form, because the form is a totally different entity on its own. It's not a database, right? It's just a tool to collect your information. But then that form can now be tied to a database. All right, so understood. Okay, so now let's move on quickly. Oh, it's past 8 already. Okay, do you want to quickly go for a break, then we'll come back? So I have quite a lot to cover. Can we go for our attendance break now? Yes, happy. It's dependent on what you set up. All right, so let's take 5 minutes to quickly go for our attendance. Please let's fill it on time. We still have quite a lot to cover, but I'm trying not to rush because we want to. These things can confuse us a lot, especially if you're not coming from a data background. Can confuse you. So 8:07. I guess we can all come back. By now, I'm sure we are all used to the attendance, um to fill in our attendance, so it should not take so much time. So we have 3 more minutes to fill our attendance form. Thank you, Levina. Two more minutes. 2 more minutes. 2 more minutes, 2 more minutes, 2 more minutes, 2 more minutes. Okay, so I think we're good to go. Sunday Christie, you said I didn't answer your questions. I'm trying to trace that question. Why is it that the email can't be a sort key since it is all about uniqueness? Um, okay, so a sort key doesn't have to be um how do I put it now? A partition key has to be unique, right? A sort key does not necessarily have to be unique. Now, a sort key is something that can help you to group things together. A sort key is something that can help you to group things together. Say, for example, you can group a group of students by the course that they apply for, right? In Incubator at the moment, right, we can group the later students by the courses that they apply for. So if I am looking for a group of uh, people, right? Instead of going to say email by email by email, I can just say give me the list of all the people that are in cloud computing, right? So I can get that basically. So now if you are saying why can't email be your partition key, it can be, right? But I am saying that me personally, I would prefer if I have an option of a student ID. If it's in a case where Lita is not giving student ID to every student now when you register, you can use the email address as your partition key. Why? Because it is unique. So you can. It's dependent on what you want it to be. But in a situation where I have a student ID and I have email address, right? I'll prefer to use student ID as my partition key. So you can also use your email address as your partition key because it is also unique. Hope that answers your questions, Christy. Christy, does that answer your question? Can we move on? Can we move on? Mm, okay. All right. So thank you. Christy, you said you didn't get me. Okay, I said that the email address can also be your partition key, right? Because it is unique. It is dependent on choice. Now, in a situation where I have a student's ID and an email address, right? Maybe my student's ID is automatically generated once a student signs up, right? I would probably prefer to use a student's ID than to use an email. But in a situation where I do not have a student's ID and I have email address, I can use an email address as my partition key as well. So it's dependent on your choice, basically. This is my preference. Hope that's is understood now, Christy. Okay, so yeah, let's get ourselves a bit more confused. So apart from the partition key, right, and your sort key, there are things called secondary indexes, right? So your primary index is your partition key, right? Which means that index is basically, how your data is, going to be, arranged, right? How every item will be arranged, right? Say for example now, this 101, if this is our partition ID, partition key, right? It's going to arrange it as 101, 102, 103, 104. So this is our index 1, index 2, index 3, index 4. It's going to arrange it like that, right? It's going to arrange it by student ID. It's going to arrange by student ID. Now, there are things called secondary indexes, right? So you can arrange your data in aside from using the partition key and the sort key, right? So that is number one. You have your global secondary index, and then you also have your local secondary index. So here we're going to be talking about global secondary index. Now, your global secondary index, or GSI, allows you to create an index using attributes that are not your primary key, or your that are not your partition key or your sort key. Now, your primary key is usually your partition key and your sort key, right? Which is your composite key. So you can use any other attribute to sort. Say for example now, in this table, remember you were saying something about us using email. In this table now, we can have our email as our our secondary index, right? Which means that if I say I want what are they calling it, this data now, right, to be arranged by my secondary index that I've said is going to be email. You say it's going to arrange this data now based on this one that have predefined. That's the word, that I've defined, that this is going to be my um secondary index. Now, what does it mean to be global? It means that whatever attribute I've made my global secondary index here, my secondary index, a global secondary index is going to cut across every partition, every item. Now, note, your secondary index is optional, which means that you can have somebody that would fill it and somebody might decide not to fill it, which is why in this example now you have Alice as an email, Bob has an email, but Clara does not have an email. What will happen is that if I decide to say I want to query this data by email, if I say give me the data of every student in liter based on my secondary index, which is what the email address, is going to give me everybody aside from what? Aside from Clara. Why? Because Clara does not have an email address. So that attributes that you make an email address can be what? It can be optional. It doesn't have to be compulsory. So that's why I wrote to say that if an item does not have that particular attribute that is indexed, right, it will just not appear when you are requesting for data that have it. Now, what it means to be global is that it's going to search through all of the items in your table, all of the partition in that table is going to search through it. Let's say 101 is a partition, 102 is a partition, 103 is a partition, right? It's going to search through all of it, all. So if I can use it to say, give me all the names of students in this school, right, based on their email address, right? Indexing their email address. So that can work. Now, the second type of secondary index is a local secondary index. Now, a local secondary index will allow you to sort your data within a particular partition, Now, let's say, for example, right, our partition is 101 and 102. Now, student 101 has registered for CSC 101, MTH 101, ZLY 101, GST 101, CHM 101. Our second student, right, student 102 has registered for this. This is their name, these are their grades. Now, you can use your grade as your local secondary index. What does that mean? It means that a local secondary index is going to be applied to a particular partition per time. Say, for example, now I have this student, right? Now I want to get um courses that he gets A in. I'll just make my index what? The grade. So it means that I can, if I make this grade my local secondary index, I can always say, give me the information of students 101 where he gets B, right? When I make that kind of a query, it's going to return what? MTH 101 and ZLY 101 to me. If I say I want a situation where you give me data of student 101 where it gets C, is only going to return what? CHM 101 to me. Now, I cannot use this LSI to apply to other partition. The LSI, that is why it is called local. It is restricted to a partition. You can use it within a partition. Unlike this global one, right, that I can apply to everything. If we add an email here now, if we add email is our global secondary index, right? I can say, give me details of students, right? I mean, based on the email address that we have, right? And to give me, depend, no matter the partition that they are, as long as the person has email address, as long as that partition or that item has email address, is going to return it to me, right? But if I'm doing a local secondary index, it will only apply to that partition. I can only use it to sort the data within that particular partition. Are we confused yet? No, okay. Okay, I should come again. Debbie, you said I should cook again. All right. Okay. So let's do this. Okay. Let me see. Give me a minute. You might not see my screen in a bit. I want to edit this table and include something to it. So give me 1 minute so that I can use it to explain better for to us. So give me just a minute. Mm. Okay. a minute. I'm trying to add something to the table to help our explanation. Okay, let me reshare my screen. Can we still see my screen? Can we confirm if you can still see my screen? Yes, okay. All right. So, confusion is of the devil. I expected this. I expected the confusion. That's why I said we're going to take it as slow as we can. All right. So, now I've edited the table, right? Um, is it bolded? Can you see it very well? Okay. All right. So, I've edited the table now, right? So, include some other attributes. Remember, we didn't have email address. So, let's use this now as our example. In this case, right, we have, oh, I forgot to change something here. 103, 103. Let's change this color. Okay. Okay. So we can see three different colors now on the table, right? Okay. All right. So now looking at this table now, right? If I have this, my student ID is my partition key, right? Student ID is my partition key. Course code is my sort key, right? Which means that I can sort this data, right? Now, one thing to note is that what your sort key is global, which means it can be applied to every every partition within the table. It can be applied to every partition within that table, right? Now, note that your sort key is, once you say that you want a sort key, it's compulsory, so it has to be filled, right? That's the difference between your index, secondary index, and your sort key or partition key. Now, for your secondary index, you have a global secondary index and a local secondary index. What does global means? When you say something is global, it means that it cover everywhere, right? So your global secondary index, right, can be used to do what? To organize your data, right, in within the table, irrespective of the partition. So you can go along, you can query your data, you can query this data now, right, based on your global secondary index, your GSI. So in this table, we have made our email. I'll beat this slide on. In this table, we have made our email our GSI. Just follow me carefully. Now, your GSI can be an optional attribute, which means that it can be an attribute that people are filling or people do not fill, right? So which means that as Seun did not fill email address, there's no problem, even though the email address is our um global secondary index. So if I want to query this table now, I can query this table based on email addresses, right? And ask that give me information, right, on this table, right, where maybe email address is equals to aj dot example. Let's assume that, oh, give me 1 minute. I'm trying to see how we can explain this that everybody will understand once and for all. So I don't think that it only applies to one. So now I've removed email address for this item that is here, right? So it means that now I can say in this table, right, give me details of every student that has what email address. Is going to return all the information. Now let's say this is our partition 1, this is partition 2, this is partition 3. In this table we have just 3 partition, right? Partition 1, partition 2, partition 3, isn't it? Now because it is a global secondary index, it can scan through the entire table and scan through all of the data, and it will return information of all those that have email address. So it's going to return to me Alice Johnson, course code CSC1, Alice Johnson, course code ZLY101. It's going to return to me Bob Smith, course code CSC101, right? It's going to return to me Bob Smith, BTN101. It's not going to return to me Sheundara. Why? Because Sheundara does not have an email address. So based on the query, because I'm querying this data, right, based on my global secondary index, which I determined by myself that is going to be the email address. Again, you can determine what is going to be your index. It is your choice. But just know that whatever it is you're setting to be your index is something that you can use to do what, query the data across all board, across all board, right? So everyone is supposed to have it. They might decide not to have it, but more than one person will have it basically in that table. So that is what a global secondary index is. Now, a local secondary index, just like the name sounds, local. When you say something is local, it means it is restricted to that particular locality, right? So a local secondary index is what you can use to sort your data, right, within a particular partition. Within a particular partition. Now, I've said in this case, we are making the grade our LSI, that's our local secondary index. And what does that mean? I can decide that, oh, I want to sort for our partition 1. Partition 1 is for who? Students 101, right? Partition 1 is for students 101. I can say I want to sort my students 101's data based on the grade that she has. So I can say give me only the grade for students 101 where she scored B. So it will return to me what? MTH 101, ZLY 101. I cannot now say that if I say give me the data of student 101, I cannot use my LSI to go through all of this. So it means that I'm now going to go through one by one and be saying students 2, give me where she got B or where she got A, whatever it is. It has to be within the partition. Now again, this is what dependent on your choice. Your grade can become your global secondary index. We can decide that grade is our global secondary index, and then we now say in the entire partition, once we make grade our global secondary index, what does it mean? We can sort the data within all the partitions, not just restricted to a particular partition or within just one partition. It can go global. It can go across all the partitions that are in the table, right? So if grade is our global secondary index instead of our local secondary index, I can say, give me the data of students that scored B. What would it do? It's going to return to me student 101 and all the courses she had B in. It's going to return to me student 102 and all the courses that he had B in. It's going to return to me student 103 and all the courses that she has B in, right? Why? Because it is now a global index, so it can cut across all of the partition. But if I say, sorry, oh, you're no longer global, I want you to remain local, I cannot ask you to give me all the information of everybody in this table, right? It has to now be restricted to within a particular partition. So now this is now going to be me saying, give me data of students 102. It has to be within a particular partition, right? So give me data of student within 102, student for student 102, where she scored or is scored B, and then it will return to. If I say give me data of student 102 where is scored A, it's not going to return anything because student 102 did not get A in any course, basically. So the difference between a GSI and an LSI is that GSI is global. It can cut across all the datas in the table, irrespective of the partition that they belong to. While an LSI operates within a partition. It operates within a partition. Do we understand that now? Yes. Okay. All right. So thank God. Okay, so let's quickly move on. All right. Thank you for understanding. Now, these ones are pretty straightforward. We don't need to do plenty explanation here, right? So, how do you manage items in DynamoDB? So, there are what you call actions that you can carry out in DynamoDB, right? And you have basically four actions that you can carry out to an item. You can put item. The way it's written together is how you use it in DynamoDB, right? So if you want to add a new item to a Dynamo table, say for example, when I was adding that new Sheondara to that table now, if I was sitting on a DynamoDB API, what I'll put there is put item, right? And then put item will be the partition key for that item, which is supposed to be the student ID, abi. So put item partition key, which is student ID, is your key. Then the value of that partition key will be 103, which is the student ID. Then I'll now say course code CSI 101, right? The grade that the person got, the email address, and all of those things. So put item is what we use to add a new item to the table. Put item is what you use to add a new item to the table. Get item, just like the name sounds, right? Is what you use to, you want to get an item. Say you want the information of students 101, for example. So you can retrieve the information by using the partition key. You can always say, give me uh, get item student ID 101, right? And then to give you the information of that item. Then you can also say update item. Update item means maybe um before students 101 was not offering FRE 101. Now she has added a new course, a new attribute to herself, right? Which is a new course that she's taking. So you want to update that course. So you are going to, instead of doing get put item, because put item means you are putting a new item with a new partition key, right? So instead of saying put item, when you want to update something, you do what? you use update item. You use update item. So update item is used to modify an existing item. Update item is used to modify an existing item. And then the last one is what? Is delete item. So you can use this to delete an item from the table. Maybe Sheondara has already left what are they calling it now? Lita cloud computing course. So you don't want to keep having her data there. You do what? You delete it. So you use delete item. Now note, each of these four action um that you can do are tied to a single item. You can use it to work on single items, not multiple items. You can use them to work on single items. So put item, you use it to add one item. Get item, you use it to retrieve one item. Update item, you're working on one item. Delete item, you are deleting one item. So you cannot say put item and then you're adding two items. So you have to do this one by one, basically. Right. Now, if you need to do more than, then you now do what? You use what? Use a query. So a query is what you use to do what? To retrieve more than one item. It is a query that you use to retrieve more than one item based on a partition key, or if you have added a sort key as well. If you did not add a sort key, you use your partition key to do it. Let me see if we can still remember. The combination of your partition key and your sort key is called what? I had mentioned it earlier. A combination of your partition key and your sort key is called what? Um. Oh no, I'm just seeing your question. That can LSI and GSI be used in the same table? Yes, yes, you can. You can. Yes, ma'am. You can. Yes, gifts. That's the answer to my question. A combination of a um what's the word now again? That I've skipped my head. Yeah, the combination of your partition key and your sort key is composite key. Composite. Composite key. Right. So if you want to retrieve multiple items, right? Say for example, all that time that I was saying I want the information of all the students, right? Based on this, maybe uh based on the partition key and the optional sort key, maybe based on the partition key and the course that they are doing, the student ID and the course that they are doing, I can use what? A query. I can use a query. Now, a query is specifically used to retrieve information. Used to retrieve information. Now, for a DynamoDB, what you can use to query your data, unlike a relational database, in relational databases, right, you use SQL, your structured query language. That's the language you use to query a relational database. But for a non-relational database like your DynamoDB, you can use a DynamoDB API, which is where you get to use all those get item, put item, delete item, and what have you, right? Or you use what we call a party QL. A party QL. A party QL is basically party query language, right? Now, a party QL is similar to a SQL query language. In short, they look the same. So it's basically a way that a lot of people are already used to SQL, right? So it makes it easier for them if they have something like SQL that they can use to uh, query a DynamoDB. So that's why a party QL was actually created. Now, unlike a SQL, because SQL is used for structured schemas, right? Party QL follows the fact and understands the fact that a Dynamo table is unstructured. It can have different schema, right? So it takes that into consideration. Now, a query will do what? It will give you answers to your questions that you ask it, right? Based on a partition key. So you can always restrict it. While for scan is another thing you can do. Scan is going to get item for the table. It will scan all of the information you have in the table. Let's say, for example, if you just say give me all the students um in our students database, right now student table, that has grade A. What will it have to do? It has to go and scan through all the data that you have. If you have 1 million students, it has to go and scan through all that 1 million, and scan through all the courses that they are doing, and go and get all the ones that you have A. So most times it's not usually advisable that you use scan, especially for when you have a very large database, right? Imagine telling a going to an Amazon e-commerce database, right, and using scan. That means you're telling it to scan all the data. So it's usually not advisable. Base time is usually not advisable. So a party QL, a party QL, this is what the syntax look like. Like I said, it's similar to a SQL language, right? So it also uses the select. So you select whatever your expression is, right? And then from whatever the table is plus the dot the index that you want it to be in, then where is your condition, and then you can order it by something. So it's just like your SQL again, right? This is majorly for those that are into data analytics or have a background of data analytics. For those of us that are not going to be specializing in data analytics or database administration, right, it's just for you to get an understanding of what DynamoDB is. And maybe you have a customer that say, oh, want to move our database to AWS. You can ask them, okay, what kind of data is the data that your database will be housing? Is it a data that changes, every time, like fast, 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 fast? If it is, then you can recommend a DynamoDB. Or is your data the type that has a structure to it? It has a fixed schema. Nothing must change in that structure of your, like a bank, right? Most banks, most transactional industries, they have a fixed schema. Nothing must change in that schema. Why? Because it will help them when they want to query. They already have an idea of this is where this data is, this is under what category this data is that I'm looking for. So it helps them when they want to query it. So for an organization that their data is structured, of course, you will not recommend a DynamoDB to them. You recommend a relational database to them. So this is an example of a particular, just like your SQL, right? So you are saying select device. Device is what you want to get, right? Devices. So it's expected that maybe in that table you have a table for devices, right? Maybe in that device you have name of the device, the country that produced or manufactured the device, blah blah blah. Then from watch list can be the name of the table that you have. So select devices from watch list where your device fire stick and fire stick is probably your index, right? Your index, and the date that they watch that device is greater than this particular date. So it's different. We can say, let's use a common example that we can use. We can say select students, right? Select students from students table, right? Where students ID is equals to this, or where student enrollment date is equals to that. Anything you want to put as your condition, right? So that's how to query data in DynamoDB. Now, I put this here because I wanted to show us something, and we'll see it in. So this is something like a relational database, right? Relational database will have more than one table. Now, in every of that table, right, there will be a primary key, right? So table 1 is course, table 2 is books, table 3 is what? Instructor, right? Now, there's a course ID for this course. The course that they have is what? Getting started with maybe SQL, getting started with DynamoDB can be the name of the course, right? This is the day that they created the course. the status of the course is what is active. Now in our books table, you have book ID, book title, and course ID. So which means that every course, right, probably has a book that is tied to that course. Then who is the person that is taking the course, right? You have the ID of the instructor that is taking the course and the course ID of that person. Now, if you want to get um information from that table now, from that database, right? Let's say you want to get the title and the book title and the instructor name, right? Remember that all of this information you want now are in different tables: title, book title, instructor name. All of them are what? Are in different tables. All your title is in what? Is in course table. Your book title is in books table. Your instructor is in what? Instructor table. Now, I need all this information. How would I now get it? I'm now going to say, give me or select, which is the language of SQL, right? Select title, book title, instructor name, right? From your course table. You can say course table, you can, instead, so that you not be writing course every time, you can denote it as C, right? So select title, book title, instructor name from your course table. Now join that course table to the books table. So we are joining these two tables together. Now when you join these two tables together, what is the common factor that they have? Course ID. Before you can join two tables together in SQL, they must have a what? A common column, right? So in this table now, this is the primary key. When that primary key comes here, it becomes a what? A foreign key, which means that you can use this one to always reference this. So for us to join this table now, we have to join it based on a common column, because we cannot get book title from only this table. So for us to be able to get book title, which is the information we also need, we need to join this table to this table. And to join it, we need to join it based on what? Course ID. Now, we also need instructor name. Is there instructor name in this table? No. Instructor name can only be found in instructors table, which means I also have to now join this to what? To this table as well. So we are going to join the course table to the books table and to the instructor table, and join them all based on what? This course ID. So if all these three things comes together now, you are going to have course ID, title, book title, instructor name, right? Create date, status. That's what you are going to have, because this is the primary table that you are joining others to. Now, you have now put a clause that where your course ID equals to what? 114. So the answer it will give you is what? You only want information on this particular course ID. So you want title. Remember, you have now joined these three tables. So it's going to give you the title for this course ID. The title is maybe getting started with DynamoDB, right? You want book title. What's the book title for this particular course ID? This is the course ID. What's the name of the book? Introduction to DynamoDB. What is the name of the instructor that is going to be taking this course? The name of the course instructor is what? Richard Roy. So in a relational database, you join tables. So you have different information stored in different tables. For example, for us in Lita now, we can have a table for students alone. Then we'll have a table for courses. Then we'll now have a table for instructor. So students will have all the students. We have another table that we have um all the courses that Lita is taking: cloud computing, data analysis, web development, virtual assistant. All the courses that they're taking will be there. They will have their own ID. So if I want to get information that involves those three tables, I have to join those tables together. That is what happens in a relational database. There has to be a join. But in a non-relational database, there's nothing like join. So because a non-relational database rather, like your DynamoDB, it does not have a fixed structure. It means that you can have multiple information in one. Say for example, now in this place, you cannot have course ID 113, then you now have title getting started with SQL. You now have course ID 113 again. Then under that course ID 113, you also have another title. You cannot have that. It's in relational databases, there's something called normalization, right? It normalizes your data. It's make sure that it's only what is needed for that particular kind of table that you have there. Any other information that does not fit into it goes to another table. So you group the information based on the relationship between them. So if you need to get more than one information now, you have to join table. But for a non-relational database like your DynamoDB, you can have all this information in one table. You can have all of this information. You can have all of this information in one table. Now, let's use this as a example. A further example. Now, this is the SQL side. This SQL has a table called products. It has a table called books. It has a table called album. It has a table called movies. It has a table called track. Now, it has a primary key, which is what? A product ID. This is the primary key. This one's primary key. This is this one's primary key. This one's primary key, right? Now, it has an index. The index is what? Is type, which means that for product one, the type is what? Book. If I want to get the author of this particular product one, what we have to do, I have to join this table and this table together. I would have to join this table and this table together before I can get the title, because the title is not in the same table as the name of the product. If I want to get for product two now, product two is an album. I have to join this album to this table so that I can get the name of the artist that sang that album and the title of the album. That is for SQL. Now for NoSQL, all of them can be in one table. So you're going to have a partition key, which is your what? Excuse me. Your partition key will be your product ID, right? And then your sort key will be the type. So all these book ID, album ID, movie ID, right? They will come under this sort key. So which means if I want to find information now of this book for product one, I can easily get all the information in one table without having to start joining. I can easily just say details of product one. It will tell me what? It is a book. This is the title of the person that wrote this particular book. This is the title of the book. This is the year that the book was created. For product two, right? You can say this is the product two, this is the album ID, this is the name of the album, right? This is the person that actually created the album. The same product two, right? In that same product two, in the album there's a track. The name of the track is. So all of it, unlike a relational database where all this information would have been stored in different tables and then you now have to start joining, you can have all of them in one table. Do we understand? Is it understood? Okay, all right. Okay, thank you very much. I mean, they say no sequel it is then. Well, yes, again, it is dependent on um well, we'll look at the pros and the cons. So you decide again, you tell me later on after I look at the pros and the cons whether you still go with NoSQL. It's depending on what your application needs, basically. Actually, everything has their advantage and their disadvantage. So provisioning models for DynamoDB, right? You can, when you want to provision, you can choose to provision output, right? Maybe you already know how you'll be accessing data, the read and write capacity. So you can always use a provision throughput for when you know you have a predictable traffic pattern. You already know how traffic would be in that database. While you can use on-demand mode for when you don't know how your traffic will be yet. So you can automatically be scaling up and be scaling down based on your workload. Now, what are the pros and cons of DynamoDB? Number one pro is what? Is scalability. Remember, we have said it before that what? It's automatically would undo your scaling depending on the amount of data that you have, right? So you don't have to manually go and start scaling basically. Now, number two advantage is what? Is that it is fully managed by AWS. So you are not managing any instances, any infrastructure underneath it. AWS manages your infrastructure, it handles your backup, it makes sure that it is automatically backing up your data automatically. So you don't need to maintain any server. Two is the fact that it has low latency, which means it's fast. To query it, to get responses from it, to write to it, to update it is usually fast, especially when you have a very large database. Then also an advantage is what? Is that it's flexible schema, just like Ayo was saying, NoSQL it is, right? Because I mean, it can come in any format. You don't have to have a fixed structure as to how your data would be arranged in the database. It can come in any way, so it is an advantage basically. And of course, it is what? Highly available and durable, because AWS will automatically make sure that it is in different availability zones, so that in case anything happens to one, the other one automatically does what? Continues basically. Now, what are the disadvantages? Query limitations, right? So your querying it is limited to the partition key and the secondary indexes. Unlike your relational databases where you can join table, right, and get more um information, right? In this time you cannot be joining table. So it can make querying become quite complex, and it is only limited to what? The partition key that you have. Only limited to the partition key that you have basically, and your secondary indexes. So that is one of the limitation. It does not have those joins. You cannot perform very complex querying. If you see some organizations when they are querying their databases, you see some SQL queries, fear will catch you. Some SQL queries can be as long as one A4 paper, right, filled with what they want the database to give it. But in a DynamoDB, your head will turn upside down when you want to write complex queries, right? Because you are not joining tables, so to say. So if everything is in one table, by the time you have a very large table, it can become quite confusing for you. Then also cost consideration. If you are using on demand, is much more expensive than your RTS. Then when you have something called consistent read means that it makes sure that all your data are always what? Up to date. Say for example, if you are getting data from social media, it makes sure that all the data that are there are what? Up to date. That is what consistent reads mean. But because of the amount of data, right, consistently updating it is what? Is usually, it can be lagging a bit, can lag a bit, right? So it might have like some milliseconds delay and all of that. Then limited transaction support. Unlike, like I said, unlike SQL that you can, it has full transactional features. You can do so many things. You can query different things with SQL, right? Because there's a structure on ground. So you already have your data schema, you have your model in your head. So if you want to query, you know that okay, I need this information that is in this table. I'll join into this table. I'll get this. I'll put a condition for this to restrict it to this, right? Unlike that, in DynamoDB, it doesn't work that way. So you cannot perform complex querying. So those are some of the pros and cons. Industries where SQL and NoSQL is used, basically finance, their data are structured, right? So SQL is better for them. Retail businesses, SQL is better for them. Governments that are, managing citizens' records, where they have strict way that they want everybody's data to be: name, first name, last name, phone number, address, date of birth, state of birth, local government. They have strict skinny. They can use SQL. Now, no SQL, social media, like I said, user A can post a video, user B can post images. If they are using SQL for that kind of a thing, SQL database will scatter, his head will scatter, because it likes structure. It doesn't like things being scattered and all about the place. But NoSQL can handle it. Gaming, right? NoSQL is also recommended for a gaming industry. So it's 9 o'clock already. It's past 9. Is there any other questions? Is there any other question? I mean, there are SQL queries that are mad gone. If you have database administrators as friends, right? Just tell them to show you one day. Show you one of their queries, their craziest queries. You'll be surprised. You'll be surprised at what they get. So are we all good with this today? Do we understand? Do we have a bit of grasping of what DynamoDB is, relational and non-relational database? All right. Okay. Okay, so I think we can call it a night. You can always go and read up on some of the resources that are here to get more understanding. I'm also available. You can reach out to me or to Mr. Moses at any time, and we are happy to answer your questions. All right, so it's 3 minutes past 9. I think we can call it a night. For those that said they sent me assignments, please just send me a DM. Let me check my LMS. Now I got notification for, I think, 2 people. So thank you everyone. Thank you everyone. I'm glad that quite a lot of us could pick up, even though we are not data analysis students. We could still understand some things from it. Sorry, there's actually knowledge check, but our time is fast spent, so I don't want to delay us more than necessary. But the knowledge checks are in the slides. When it is uploaded, you can always check them out. All right. So good night, everyone. Bye.